There's algebra. We're going to have equations, inequalities, and that is question number 1. And then we're going to have number patterns, or sometimes we call it series and sequences. Then we're going to have functions and graphs. We're going to have some questions on finance, growth and decay. Then we have differential calculus, and then we have the counting principles or the probability. So the paper will be out of 150 marks. Okay, and then the time is 180 minutes, which is roughly 3 hours, which means 1 mark approximately for 1 minute. So the mark allocation is that question 1 carries basically plus minus 25 marks. No? Then the next question of the topic, number pattern sequence series, usually carries 2 questions, which is plus minus and 25 marks. And 5 marks. Then for the functions and graphs, plus minus 35 marks. Then finance will cater for 15 plus minus. And then calculus plus minus 35. And then probability is plus minus 15. So that we have a total of 150 marks. So what are the expectations? Okay, what are the expectations in all of this? So let's see, I'll just break it down and start with algebra, which is more like question number 1. Okay, so when you look at this, under algebra, they're telling us that we're gonna be solving quadratic equations, which is true, but we're not gonna use the difference of 2 squares. Okay, we're not going to use the difference of 2 squares. So what are we going to be using? We're going to be using all the other methods of factorization and the quadratic formula. Remember, the quadratic formula is obtained from the completing of squares. So we don't need the completing of squares, which is the long approach, but rather we use the simplified approach, okay? Quadratic formula can be found on the back page of the paper. So this is out. Our main focus is just the factorization or factors, and then the quadratic formula. Okay, then you need to solve quadratic equations using the substitution of the K method. This is examinable. It's possible that it can come where you have maybe an equation with a bigger exponent other than 2, maybe x to the 4, probably x to the 6, and so on and so forth. So when you use the K method, you let K be maybe x squared, so that you just replace that and then you solve it. Then equations involving sides, these are the square roots that lead to quadratic equations. These are examinable, and we need to pay attention to this, especially when you're giving your answers. We always encourage people to test their values afterwards. Okay, solutions of non-quadratic inequalities. This can be asked under the functions, and then the nature of roots can also be asked under the functions sometimes. Let's just have a look at just an example of question 1. Okay, here we go. Solve for x, correct 2 decimal places. So in most cases, when they tell you 2 decimal places, they would expect you to use a quadratic formula, but it's up to you anyway. So you can choose the factors where you feel you can get the factors, and where you can't get the factors, just use the quadratic formula. But if you're a person that just specializes in the quadratic formula, please stick to that. What we need is the marks. Ne? So this, just get your A, your B, and your C values, substitute the quadratic formula, or get the factors and then get the answers for x. Then for the second part, create the standard form first. So it's 3x squared. Okay, what's happening? I say 3x squared minus 17x. Okay, plus 8 is equal to 0. And then you can go on to solve. And then with the inequalities, you need to pay attention to the A value. Okay, whereby if the A is positive, and then the symbol of the inequality is greater or equal to, then your solutions must be x is less than the smaller value, x is greater than the big value. Okay, and then if the A is positive, and then the inequality is less or equal to, then the small value is less or equal to x, less or equal to the big value. So just pay attention to the sign and the direction. Okay, 1.2, these are exponents. So with exponents, just make sure that the bases are the same. Since these are exponential equations, make sure the bases are the same. Express a 4 in a base of 2. In this case, they just want you to show that. Then simultaneous equations, remember, we always have a linear equation, okay? Which you call maybe equation 1, and then you call this equation 2, and then you just do the substitution. That is to do with the simultaneous equations. They carry quite a lot of marks. So and so on and so forth. So that would be question number 1. Then let's look at this other one. Probably let's just snip into it and see how a question 1 would look like. Okay, here we go. So in this case where you have brackets and then they're asking you to solve for x, we don't necessarily have to open up the brackets. Just use the dot product where x minus 7 is equal to 0 or x plus 4 is equal to 0 and then solve the values. Or alternatively, just get these numbers and then switch the signs. So x is 7 and x is -4, something like that. Then in this case, where the question comes with a condition of 2 decimal places, that is the quadratic formula. Then 1.1.3, where we say the sides. You know, you square both sides, get the values, get a quadratic, and get your answers. Then those answers, we need to test them on the left-hand side of the original expression, and then on the right-hand side. So if we get a scenario whereby we get the same answers on the left and on the right, then that value will be a solution. And then if we get an answer that does not give us the same value on the left and the right, we just cancel it out. Or you can just say not applicable or no solution, something of the sort. 1.1.4, create a standard solution or the standard equation. You move the 4 that side and then you solve that. For 1.2, it's a simultaneous equation, a 3x, a y, a 5, and all of that. So we have the linear, and then we have the quadratic equation. So start with the linear, manipulate it around, make one of the variables the subject. So you can leave y on one side, move the x that side, and then you get that y, substitute into there. Then 1.3, calculate. So the square root with these exponents. So in such a case, break down the bases to just the smallest base, and then do the factorization since we have a plus. So when you have a plus or a minus with exponents, factorization is always a must. So that is how the question 1 would look like. Okay, then I'm moving on to the second part, which is normally the sequences and series, number patterns. So number patterns, sequences, and series. So what they tell us that the sequence of the first difference of a quadratic is always a linear pattern. Therefore, knowledge of linear patterns can be tested in the context of what we call the quadratic patterns. Then recursive patterns, we're not gonna ask you about that. Then we must link between the patterns that were done in earlier grades. And so remember, guys, that when we talk about number patterns, we have what we call the arithmetic, okay? We have the geometric, and then we have the quadratic. What is important with all the 3 is that we need to know what their TNs are, the nth terms, okay? The a plus n minus 1 into d, the AR n minus 1, and then the AN squares, the BN, and then the C. So all these need to be known, whereby A represents the first term for the first 2, and then N is the position, and then D, in this case, is the common difference. In this case, R becomes the common ratio. Okay. Then when you're dealing with, let's say, the quadratic, we need to remember the 2A, the 3A plus B, the A plus B plus C. We need to use those expressions. Then okay, so the other thing that we need to remember is also the sum. Okay, we need to know our formulas. Sum of an arithmetic is n over 2. into 2a plus n minus 1 into d. For the geometric, we need to know that it is a into 1 minus r to the exponent of n over 1 minus r. And then lastly, we need to know the sum to infinity, a over 1 minus r. So this we need to know, and how to apply them is also important. Then the other thing about the sums is, let's say you're given the sum of maybe n squared plus n. The sum of any pattern or sequence or series is given as n squared plus n. Then they ask you to use this to determine, let's say, the pattern itself. And so we know that S1, that will be the sum of the first term, is always equal to T1. Replace n with a 1. You're going to have something like 1 squared is 1 plus 1, that's a 2. Then for us to get S2, the sum of the first two terms, that will be 2 squared, 4 plus 2, that's a 6. So what I need us to know is the link between the sum of the terms and then the term themselves. What this means that for us to get, let's say, the second term, you must get the sum of the first two terms minus the sum of the first term. For us to get T3, we shall get the sum of the first three terms minus the sum of the first two. But what we know is that T1 is equal to S1. Okay, so what this means is that T of n is equal to S of n minus S of n minus 1. For us to get term 3, you must get the sum of the first 3 minus the sum of the first 2. So this is also possible. Okay, so we have the sums to infinity, arithmetic, geometric, and all of that. So R is the common ratio, A is the first term, and then we're good to go. Okay, so that is how these geometric patterns and series can be asked. But then we also have what we call the converging series. Okay, converging series. We need to know this as well. So for series to converge, there is a condition that -1 must be less than R, must be less than 1. In other words, the ratio must be between the intervals. But in most cases, the ratio that is given is in terms of other variables, maybe P, X, and so on. And then we need to work that out. So if let's say we have 2x minus 1 as our common ratio, if we put it within this interval and then we solve for the x, you move the -1 to either sides, it's going to be a plus 2 that side. And then this side is going to be a 0, is less than 2x. Divide through by 2, 0 is less than x, and then is less than, let's say, 1. So this is the interval within which that sequence, that imaginary sequence of ours will converge when R, or when the common ratio is between those values. So that we need to remember. So that is to converge. That means the series will just become smaller, smaller, and narrower. Okay. But then for series to become bigger or to diverge, which means your R has to be greater than this one. If this was a number, maybe a 4, then R has to be greater than 4 for that sequence to diverge or become bigger. All right, so that is what we need to know with the sequences and with the series. Let's just snip into the papers and we see. Okay, we have this, which I didn't mention. Thank you very much. It's here, sigma notation. So sigma notation means just the sum or the summation. For you to work around with the sigma notation, you need to first of all determine the type of sequence it is. Is it arithmetic, geometric, or quadratic, depending. Okay, we can do that by just substituting these 3 into this, the 4 into that, and then the 5, because the sigma notation is telling us that n must start at 3 and must end at 20. So after getting those terms and determining whether it's arithmetic or geometric, so let me assume this is arithmetic. Okay, I'll have to get my A, and then I'll have to get my D, and then bring in the sum of the arithmetic, which is n over 2 into 2a plus n minus 1 into d, and then do the substitution. How do I get the number of terms? I will get my last term where I'm ending, which is a 20, minus the starting point, which is a 3, and then I'll have to plus a 1. So in this case, our n will be something like 18, and then I'll use n as 18, and then apply all of that. Remember, it's a T2 over T1, or T3 over T2. That's how we get the common ratio, not the other way around. Same applies with the differences. When you're getting the differences, the T2 minus T1, which is the same as a T3 minus T2, just between consecutive terms. Okay, so in this case, our ratio would be 3x minus 1. Okay, then they're asking for which values of x. They're not asking for r. Of x is the series going to converge. Then bring in that condition. -1 is less r and less 1. And then get this r, replace it, and then make x the subject in that case. Then sum to infinity, we know the formula a over 1 minus r. So after doing your substitution of x as a half, you'll get your first term. You replace x as a half, you get your T2. And then get this a, and then between the two, get the common ratio. You can just get x, substitute it here, and then you have your common ratio. And then work the question out. So that is one question. Okay, there's another one here. We have 2x12 and y. They're telling us their first 4 terms of a quadratic. Sometimes they'll tell you what sort of sequence it is. So if it's a quadratic, just know that we have 2 differences that are involved. Okay, so 2, we have x, we have 12, and then we have y. So this and this is going to give us our first difference. But then they're telling us that the second difference that we're going to have here must be equated to a 6, according to the information given. So whatever we get here is a 6, and then whatever we have here must also be a 6. So in that way, we shall be able to solve x and y. And one other thing that we need to remember is that it's also possible for simultaneous equations to be brought just in the format of sequences and series. Okay, that was just one paper. Let's look at the other one. Okay, so with this one, they're telling us we have a quadratic. Okay, there we go. So we can get the first difference, which is maybe 18 minus 5, which is a 13, 37 minus that. I don't know. Is it a 9? 29? 19? Okay, someone is saying 19. And then you subtract that and you have your first difference. And then within the first difference, you get your second difference, and then you determine the Tn. So here, whatever we get for the second difference is the 2a. This 13 is going to represent the 3a plus the b. Okay, and then the a plus b plus c must be a 5. So 2a is equal to what's 19 minus that? It's a 6, something like that. And then you solve that. Whatever we get for a, we substitute it there. The a and the b we have, put it there. Then we got our terms, a, b, and c. Then determine the number of terms. Now, for you to get the number of terms, you should have been given the last term, the Tn. So where there is Tn, we're going to put 557. We have our a, we have our b, we have our c. Then we solve for n. Remember, when you're looking for n under sequences and series, your n should never be negative. And then your n should never be a fraction, because we're talking of a position. Positions are countable, okay? So in that case, not a negative, not a fraction. If ever we get a negative fraction, we discard those values and just focus on the others. And 2.2, we have 10x, y, and so on, the first 4 terms of an arithmetic. So follow the rules of arithmetic. There's just one difference. You just subtract x minus 10. That will be the first difference. And then we have y minus x. That will be another. And then negative 14 minus y will be another. Then these differences have to be the same since it is arithmetic. It's constant. Then equate this. And then also equate that. So it will be more like a mini simultaneous. You get x, then you get y. 2.3, just the same thing, determine the sum. So it's arithmetic, use the sum for arithmetic. And then the mth term of a sequence of arithmetic is k, the kth term is m, determine the common difference. So in this case, use the TNs, since they say the mth term, the kth term of what? Of an arithmetic. Use the TN of an arithmetic, and then we're good to go. All right, so we move on. So that is sequences and series or number patterns. Ne? The next we have what we call the functions. I'll just go up a bit. Functions. We need to know and use and interpret the functional notation, okay? When teaching the process, people must know how f of x will be transformed. Remember we said f of x will be the same as the g of x, will be the same as the h of x, the same as y itself. Ne? So when you have f of x, but then it has turned out to be f of negative x, this is a reflection about the y-axis, okay? Then if it is in this format where it's negative f of x, it's a reflection about the x-axis. Then if we have f of x plus a, this is a shift. In other words, the graph has been moved some units. So it's a units. If it's positive, it's going to be to the left. And then if it's a negative a, it's units to the right, a units to the right. And then if we have f of x, and then plus a, which a represents any number, this a is going to represent a shift, which is vertical, okay? The graph is being moved up or down, and so on and so forth. So trig functions, these can only be found within paper 2. Now, with the functions, we need to remember we have different types of functions, and we need to pay attention to all of them because most of them are examinable. Okay, an example, I'll start with the first one, which is maybe the exponential. This one is common, it's always there. With exponential, the exponent is x, probably plus a q. This q represents the asymptote. We need to remember that, okay? We need to know at least how to determine the domain. The domain, you don't need to stress. X is a set of real numbers or an element of real numbers. Problem is the range. Range, these are y values. So y values are always affected by the asymptote, okay? Always y is greater than the asymptote. Then we need to know when is the exponential increasing or decreasing. We need to go over that because sometimes they can ask you to do the sketch. Then we also need to understand how to determine the inverses, okay? Most cases, it can be of an exponential function. So the shape is usually in that sort of format. So remember that. That is to do with exponential. Then 2, we have the parabolas. Parabolas always have to be with another graph. In most cases, either parabola and a straight line, parabola with exponential, or parabola with a hyperbola, okay? So that is x squared plus bx plus c. It's a cubic function. We also have ax plus p squared, and then plus q, where p and q represent the turning point. And then we also have a into x minus x1 into x minus x2, where x1 and x2, these are intercepts, okay? The points where the graph is cutting the axis. And then we also have so parabolas, we have the smiling one if a is greater than 0. And then the frown face if a is less than 0. Then we have the hyperbolas. Hyperbolas, so if the denominator is having x involved, né? So a over x plus maybe p plus q. So with the hyperbola, we need to know how to get the asymptotes. So with asymptotes, we can say x is a p or y is equal to a q, depending. If this is a negative, then x is going to be a positive. Say it's a positive, then x is going to be a negative. These are asymptotes, guys. Okay, so having obtained the asymptotes, we also need to know okay, then remember with the format of a hyperbola, okay, there has to be 2 arms, whereby if a is greater than 0, we expect the arms to be in that format. And then if the a is less than 0, okay, we expect the arms to be in the second and then the fourth quadrant. Then what we need to also remember is how would we determine the axis of symmetry with the hyperbolas. So we have 2, one with a positive gradient and then one with a negative gradient, okay? Now they will tell you, they can ask you, determine the equation or axis of symmetry that intersects with the graph, okay? So in that case, if this was the case of the parabola, the hyperbola, then you look for the one with the positive gradient. And then we use that. And then in the case where they tell you, they determine the axis of symmetry with a negative gradient, then you use the one with the negative x plus c. Now, how do you get the c? Use the points of intersection of the asymptotes. Okay, so that is all we need to know. And then remember, with the transformations that happen, let's look at a snip into these questions. There's question number 3, which question number 3 is a hyperbola, so 12 over x minus 4 plus 6. So you can see that this is an asymptote, and then that is also an asymptote. Then when they ask you to sketch, in most cases, you will need what we call the intercepts. So for you to get the intercepts, remember for x-intercept, okay, y has to be a 0. And then for y-intercept, x has to be a 0. And then you just have to get to these points and then know the shape of the hyperbola. Because now our A is a 12, so we expect the hyperbola to be in quadrant number 1 and quadrant number 3. So even if a quadrant does not have any coordinates that you need to plot with, just draw the arm there so that it is 2 arms of a hyperbola. Okay, then write down the equation of k if k is a reflection. Now they are reflecting about the x-axis. Then you'll have to sort that out. And then question number 4. We have now a parabola and then a straight line. Okay, so use them to determine what you need to get. Then one other thing I need to really emphasize, okay, let's say the turning point of D. So turning point, you know what to do. Axis of symmetry, x is equal to negative b over 2a. We need to remember that as well. And then for us to get the coordinates of a and b, those are intercepts. We mentioned that upwards. And then the value of k, we're seeing that k is the y-intercept. Okay, so for you to get the y-intercept, you need the coordinates of A, at least a set of coordinates that is passing through the graph of G, which is A. And then that is going to give us the missing part. And so on. Now we can see this, what 4.1.4. They're asking the values of P for which it has no real roots. Now this is nature of roots being questioned. And then we need also to remember how to answer questions when you have f of x times g of x is greater or less than 0 and so on. And then with tangents, we need to also apply some bit of calculus sometimes. Okay, calculus could be needed, especially with such questions of tangents, because there's going to be need for the gradient and all of that. Okay, they're telling us this is a tangent of f, but with this tangent, we can see that the gradient is clearly a negative 2. So what you need, get the value of x, where the gradient is a negative 2. So find the first derivative of f, equate it to negative 2. So for x, get the value substituted back into the original. And then we have this also to do with the shifting and the transformation. We need to pay attention to that. Look at question number 5. We have the graphs g of x and f of x, but then the drawing is showing the inverse. Please pay attention to that. And then you just need to know that with the inverse and the original, we just switch everything around. What is x becomes y, what is y becomes x. One point for which both graphs will pass, remember this is f, ne? It's not the g. So just switch these points, 1 and 4, or 2 and 16. Then equation of f, for you to get f, you need a set of points. Whenever you're looking for unknowns of any function, you need a set of points. Okay, if there are 2 unknowns, then you're gonna need 2 coordinate pairs to get those 2 unknowns. Then calculate x if g of x, now x plus 2, this is a shift. The graph is being shifted 2 units to the left. And then we answer that as well. Okay, that is one paper. Let's see this paper. What does it have under functions? Could be more or less the same thing. So we have this. The exponent is x, so that's an exponential equation. They want the asymptote. Remember asymptote? You said anything that is extra there. Then the range is affected by asymptote. Coordinates of the intercepts, we discussed that, and then drawing, for as long as you know the shape, because now our b is a fraction, so which means this is a decreasing function. And then we have this sketch below, not drawn to scale, represents a parabola. They never told us that, but it is x squared, so it's a parabola. And then we have a straight line. It cuts that and that, blah, blah, blah. And then here we go. They ask us to determine the length. Now, whenever we're looking for length of lines that are parallel to the x-axis, parallel to the y-axis, in other words, just horizontal and perfectly vertical, you don't need to use the distance formula. What you need to do, you need to get the coordinates of B and then the coordinates of C. These are intercepts. And then get the number of units. Up to the 0, get the number of units up to the C. And then plus these 2 units. That will be the distance. They want the coordinates of D. They told us that D is the turning point. Remember, with the turning point is negative B over 2A. Then there's a straight line that is parallel. These things parallel to G. Touches F at M, coordinates of M, calculus involved. There's some bit of calculus because we need the gradient. We know that with parallel lines, the gradients are the same. With perpendicular lines, the products of the gradients will give us a -1. Then when they ask for the values of x for which f prime, remember f prime is the first derivative, which first derivative focuses on the gradient. Okay, gradient. Then when they ask for maximum, you look at the turning points. Then question 6 is a restricted function with a condition or restrictions. So we have a point A with an unknown, so which is P. Then they want you to get P. So for you to get P, you need a set of coordinates. No, we don't need a set of coordinates. Just substitute this into the function itself because this is the set of coordinates. So where there is Y, put a 4. Where there is X, put the P. And then we're good to go. Then determine the equation of the inverse, just switch. Where there is X, you put a Y. Where there is a Y, you put the X. And then the condition must stay the same. And then for which values of X, for which values of X is the f of X greater than the inverse. So for a graph to be greater, it must be just above. So let's say I had plotted my point. I don't know what this is, but let me just sketch something. And then I have something like that. Let's say this is my inverse, and then that is my f at this point of intersection. When they say the f inverse is greater, we focus on this point because the f is above. But then when they ask for f being greater than the inverse, where do we find f to be above? We'll remember that as well. Then we have this hyperbola. They gave us the conditions. So domain, those are x values. X cannot be this. This is an asymptote, the vertical. Then range is this. Y cannot be that. This is a horizontal asymptote. Then G of 2 is 0. So remember the original must be G of X is equal to something. But now they're telling us G of 2. So where there is X, we've replaced it with a 2. So that's the coordinate point 2 and 0. Because this is a Y. Okay, so they want you to determine the equation. So use those facts. Where there is X, you're going to put the 5. Where there is Y, you're going to put the 1 somewhere there. But then the signs are going to change for the P. All right, that is to do with the functions, okay? Then from there, we can look at the finance questions, okay? So under finance, growth and decay, they're telling us we need to understand the difference between the nominal and the effective interest rates and how to convert nicely, because this formula is usually not on the formula page. 1 plus I nominal over n to the exponent of n. Some people would use m. Let's just confirm and see if that formula exists, because we don't have to stress about things that are already there. Nominal interest, nothing. It's not there. Nothing. So That formula, we just need to know it by our heads, by ourselves, okay? And then you work out that. So the ends are either going to be compounding periods of monthly, where it's a 12, quarterly, which is a 4, half yearly, which is a 2. Sometimes half yearly is known as semi-annual. I saw a question that talked about weekly. Okay? How many weeks are there in a year? It's 52, no? Not 54. 52 weeks. That okay. Then with the exception of calculating I, okay, they're not going to ask you for I under annuities. But all the other variables, the X, the N, all of them, they can be examined. Okay, so F represents the future value. Okay, and then P represents the present value. To calculate the value of any other variables, pyramid schemes, they're not going to look at them. So when they talk of finance, we need to know, number one, when you talk of, let's say, growth, then you use the compound formula, 1 plus I to the exponent of N. When we talk about decay, we have different types of decay. Number one, we have what we call the reducing balance. Okay, it's A into P1 minus I to the exponent of N. And then straight line depreciation is P into 1 minus I N. All these formulas are on the formula page. Okay, then all these apply if you're dealing with just a lump sum. Or either it's a loan or it's an investment or whichever amount it could be, but just a lump sum. Then apply the correct compounding periods where you divide by N and then multiply by, if it's a 12 monthly, divide by 12 and then multiply by 12 to get the number of periods. Then if, let's say we're dealing with payments that are regular, okay, regular payments, either you're gonna pay them monthly, quarterly, half yearly, and so on, it's continuous. These are what we call the annuities. Okay, so we have two. We have what we call the present annuity. This present deals with the loans. If you borrow money and you have to pay it back, that's present. Then we also have the future. We need to know about the future, which is F. This is the P. Okay, so this deals with investments. And then what we call the sinking funds. Okay, sinking funds. Now, there's a question that is usually asked, especially under the present value, that is to do with the outstanding balance. So for you to get the outstanding balance, use the present value formula. Okay, and then where there is N, let it be the remaining period to clear the loan up. And then you get your outstanding balance straight away. Okay, that is that. Then we need to remember at least the grade 11 concepts of finance, that is to do with the timelines. Okay, so that's all we need for finance. The rest are just a walkover. Let's see. Let's snip into the questions. You know, my question 6 or 7. Here we go. Convert 14% compounded monthly into an interest rate that is compounded quarterly. So use that 1 plus, that's going to be 14% compounded monthly over 12 to the exponent of 12. Is equal to 1 plus, this is a percentage which we don't know, I, but it's compounded quarterly over 4 to the exponent of 4. And then simplify this. If you are getting rid of an exponent, use the roots. In this case, we use what we call the 4th root, the 6th root, the 8th root, and so on and so forth. And then look for the I. 6.2, this person deposits this into an account. 3 years later, he adds. Okay. So which means there is inconsistency. Okay. 3 years later. Then the interest for the first 2 years changes. The last 3 years. So in this case, we're going to use what we call the timelines, grade 11 aspects to work this out. And then 6 point next. Oh, there's no 6 point next. Question 7. Mr. Daniel wants to take out a loan. Okay, we said loans form what we call the present value. They gave us the period, which is 20 years, and they want the total cost of option 1. So for you to get the total cost, what is missing is the monthly payment, which is X. So get the monthly payment, multiply it by the number of months, which is 240, and then you plus the commissions. That will give you the total payment. Which option is the best? If you get this and that, the total that you have in 7.1, can also multiply this 10,000 times 240, multiply the 200 by 240, get the total, and then compare the loan amounts. And then you draw your conclusion. Okay, let's look at this other one. What kind of finance questions were there? Okay, Tandy invests this much for a certain number of years. She earns interest rate at this compounded quarterly. The final value is this much for how many years? Now they're asking for the N. And they gave you the P, they've given you the A, because this is our A, that's our P, that's our N. And then you just substitute. We have our I here. Substitute into the formula of compound interest, because this is just a lump sum. 7.2, this person takes out a loan of 500,000. So this 500,000 becomes the present value. That's the interest rate. It's compounded monthly. Then the bank requires him to pay off the loan in 8 years with equal installments starting 1 month after. Okay. So the normal standard period that we give is just 1 month after, then you can start paying off your amounts. But if it so happens that you take some time before you start paying off, let's say you take 6 months, this amount is going to grow for the first 5 months. Okay. And then whatever you get there, that will be your new loan amount. If you start immediately, then you'll be cutting short the number of years or the periods. It will be less than exactly 8 years. So you need to bear that in mind. Outstanding balance after 5 years, remember the period was 8 years. So if you get 8 minus 5, you're going to have 3 years left. 3 times, this is monthly, no? We're going to get 36 months. So use the present formula, okay, with the same installment that you got in 7.2.1, where there is N, put a 36. Whatever you get becomes your outstanding balance. And then this person decides instead to pay off the loan with just 95 monthly installments. Okay, of just 7.3 everywhere. And then calculate the 96th installment. So we need to know how much would be accumulated with 95 installments. You can use the formula still of the present and see how much will be outstanding. So in case it could be maybe even a fraction that is left, just a fraction of a year or a month that will be left, which amount would be less than the 7.3. Okay, so that is finance, and that's what we should expect. Plus minus 15 marks. If we can get 3/4 of them, well and good. Next, we have what we call the calculus, differential calculus. Okay. So differential calculus, we have notations that we use for differentiation. Number one is what we call the f prime, okay, of x. Sometimes we just call it the dx, and then dy dx, or sometimes it's just the y prime. It's the same thing. We need to know how to work out the first principles. Okay, how do we factorize from first principles? And then how do we apply the rules, the differentiation rules, and then the applications. Okay, here they are telling us that in respect of cubic functions, candidates are expected to determine the equation of the function. Remember that is ax cubed plus maybe bx squared plus cx plus a d, where d represents the y-intercept. And then we can use either the long division or the synthetic approach in doing this. Then you need to discuss the nature of the stationary points. So these stationary points are basically the turning points, either the local minimum and the local maximum, and then the points of inflection. So for you to get the stationary points, remember, you need the first derivative. For you to get the points of inflection, you must get the second derivative, or you must get the midpoint of these points of the stationary whatever. Then apply the knowledge of transformation on a given function to obtain the image. Okay, candidates are expected to be able to draw. Okay, so when you're drawing, the A has an effect. If A is positive, then you're gonna have this kind of shape of a cubic. If A is negative, then you're gonna have something like that. Bear that in mind. Then that is the graph of the derivative of a function. Okay, so if this is derived, if the cubic function is derived, you're going to end up with a quadratic, no? Which quadratic? If let's say our x here was a 2, then our x here is a 4. 2 and a 4 will instead become the roots of that quadratic. So that is a 2, and that is a 4. Okay, so candidates are expected to be able to draw and interpret the graphs, okay? Then surface area and volume will be examined in the context of optimization. In other words, when they're asking for minimum and maximum surface area, maximum volume, these you need to know. And the formulas, you need to have them ready because they're not going to give you these formulas. Okay, candidates must know the formula of the surface area and the volume of right prisms. Okay, rectangular prism, the cube, and so on and so forth. This will not be provided if optimization question is based on the surface area volume of the cone sphere. And so on, the relevant formula will be provided in that question, not on the page, just within that questions. So you have to select the correct formula from the list because sometimes they can give you more than one. All right, so let's see. In this case, they are telling us f of x is 3 minus x squared. Determine f prime. Remember, f prime is different from the f negative 1. F negative 1, key inverse. This f prime is just the first derivative. So the formula for first principles, we have the limit as h tends to 0, f of x plus h minus f of x divided by h. And then you apply the correct measures. Ne? So where you have your f of x as this, what you need is the x plus h. So where there is x, put x plus h. And then they tell you to determine dy dx. So in this case, you need to know that whenever you have root signs, you can change them to exponent a half. Okay, and then if the root sign is down or the cube root, you can always move it up and then the exponent sign changes. When you look at 8.2.2, they want dy dx. Step number 1, you're going to have to factorize the y. Make y the subject before you find dy dx. Okay, so y is out, you have x minus 1. On the right-hand side, I can factorize that also, x minus 1 and x plus 1. Divide both sides by x minus 1, x minus 1. That cancels. So our y is just x plus 1. And then we need to differentiate this. So the answer here is just a 1. Okay. So where do the marks come from, or where do we allocate the marks? Just this thing of factorizing and simplifying, because this derivative is so quick. 8.3 times the value of x, where the gradient of the tangent to this graph is equal to -8. They want the value of x, where the gradient is -8. So open this thing up. Okay, so it's x minus 5. Open the square brackets using the FOIL, then find the first derivative, then your first derivative, I'll say f prime of x equated to the gradient, which is -8. So we equate the first derivative to 0. Okay, first derivative is equated to 0 if you're looking for turning points. Oops, why am I rushing it? Maybe it's even the next question. Okay, they gave us a function. Here we go. Represented by the sketch, we have -1 and 36, and then b is a turning point, while g is a tangent of f, and boom. Show that p is that, and q is that. We have 2 points, guys. Ne? We have the 30, so that is a 0 and a 30. Then we have -1 and a 36. So this is going to involve some sort of simultaneous. Looking at the mark allocation, and we have how many unknowns? We have 2 unknowns that we need to solve for. So first get this 0 and 30, substitute it. Where there is f of x or y, put a 30. And then that is going to give us the same thing. So this is not going to help. Let's use this. -1 and 36, substitute it. We're going to get the first equation. Then get the first derivative of x. Then where there is x, so that's going to be 3x squared plus 2px plus a q. And then we know that this first derivative is going to be equal to a 0 because it's a turning point, and the gradient at the turning points will always be a 0. Then x is a negative 1. Then you substitute a negative 1 here. So it's going to be a 3 minus 2p plus q is equal to 0. So you can create another equation from here. And then you solve the two equations simultaneously. Your p's and the q's must come out. Then they ask for the value of c. Okay. So with c, we know that this line is parallel to the x-axis. Is that true? While g is that which cuts f at c. It looks like yes, it's parallel to the x-axis. Okay, if that is the case, which means the equation of this line is just going to be y is equal to 36, and then equate this to this equation or to this f. So where there is f or where there is f of x or y, put a 36 and then solve that equation. You get 2 points. One is going to be a with a negative 1, and then that is the c coordinate that they need. And so on. So the rest will be just application questions, and then they ask you to draw the graph of a derivative. Draw the graph of a derivative, clearly showing the intersection. Remember, we said the derivative is going to be a quadratic. So that is that. Then you have question 10. PQRS is a rectangle with P, the curve H of X is X squared, and all of that. X is 6 with boundaries. Can we show that the area of PQRS can be expressed at that? So in this case, they'll give us a formula, which formula we shall move towards to. So this is what they are looking at. Now, what did they give us? They gave us the equation of H as X squared. So do your magic. This line is a 6. They told us this is a rectangle. So do what you have to do with the area of the rectangle, length times breadth, and so on and so forth, and determine the largest possible area. So for largest possible area, you use the derivatives. First derivative, and then equate that to 0. Then solve for x. The answer for x, put it back into the area. Okay, you bring it back into the area, and that will be the maximum possible area. When I look at this question 8, same thing, first principles, we just need to know how to work that out from the rules. Then in this case, you have to move the x to the top. Please, when you're moving the x, the 2 will still stay down. So that will be like x to the negative 5 over 2 minus 7x plus 4b cubed. The question is telling us to find the derivative with respect to x. So we shall derive the first term and the second term, but this is going to be looked at as a constant because it doesn't have x. So we cannot say 3 times 4 is 12 and then no, this is not x. So that is going to fall away. And then when you have something like this, split up. So 5x to the 4 over x squared plus 3, we said x to the half over x squared. Simplify that using the laws of exponents and then find the derivatives. Then we have another cubic function, more or less the same. And they want us to find a and b. So do the same thing. You have this point, which is a turning point. First substitute it there. You get your first equation. Then you find the first derivative. Okay, equate it to 0 and then replace x with a 1. Just link to what we saw there. That is done. Determine the coordinates of b. What is b? B is a turning point. So get your first derivatives and then equate to 0. So we said for turning points, the first derivative must be equated to 0. You solve for x. And then a tangent touches f at x is equal to 4 times the x value, where the point is that. So get this 4, put it into the equation of f, determine the y value. Okay. What do they need? They want the x value of the point where the tangent intersects with this. So you get that point, and we know that a tangent is just a line that touches the graph just at one point. And then apply your knowledge there. Then determine the values of k for which exactly 3 distinct roots. So this is also nature of roots in a way. Okay, then question number 10, rectangle ABC is inscribed, an ellipse, blah, blah, circumference is a rectangle, and then the equation of the ellipse is given as this. Okay, then what do they need? They're telling us to get the maximum area, calculate the maximum. So you need to get the formula for the maximum area and all of that. So we have the coordinates. No? From here up to here is x. From there up to there is also negative x, which means your length is the same as 2x. And then this side, this is a y. And then this must also be a negative y. So which means the breadth is going to be that much. So for you to get the area of the rectangle, what we need to do, you can just substitute x and y, because we need just one variable, y to be on one side and the x to be on the other. Substitute, since these points are intersecting, make y the subjects and so on. Okay, so that is how the calculus would be like. All right, then I'm moving on to the last aspect, which is probability or counting principles. So with this, we need to know what we call the dependent variables. Okay, but we're not going to use conditional probability. I don't even want to discuss that, where they tell you probability of A given that B has already occurred. This is out. Just dependent. Dependent events in which an object is not replaced. This normally comes under the tree diagrams. Let's say you're picking marbles or you're picking sweets from a bag and then you don't replace the sweets. Okay, then questions that require a learner to count the different number of ways that objects may be arranged in a circle or use of combinations are not in the spirit of the curriculum. So we don't count in circles, but rather the way that we've taught our learners. In respect of word arrangements, letters are repeated in the word can be treated as the same, indistinguishable, or different, which is distinguishable. The questions will be specific with this regard. They'll tell you whether the arrangements must be kept the same or different. Okay, so with this probability, we need to remember our concepts of grade 11, okay, where you talked about how do you prove that events are independent or dependent using the convergence tables, okay, two-way tables. You need to at least go over the old tree diagrams, how to draw the tree diagrams and obtain the outcomes. There is this question that always brings memories, which is the Venn diagram. So with Venn diagrams, remember, we always prefer the 3 set 1, as much as the 2 set 1 can also be examined, since it's a previous grade. So this we need to know independent and all of that. Then the probability rule or the addition rule, which is probability of A plus probability of B. This is on the formula page, A plus B, or A and B. And then we need to know something to do with mutually exclusive. How does it work? So mutually exclusive, we know that the probability of A and B is equal to 0. And then for as long as the events are independent, this is what they love, or probability of A and B, that's going to be probability of A times the probability of B. This we also need to remember. Then with the grade 12 probability, those are the counting principles where you talk about the factorial symbol. What is 7 factorial? That's when you're looking for different ways in which 7 can happen. An example, if you have 7 letters, is it 7 letters? No, let me just use the word 7. Not 7 letters, but 5 letters. And then we want to rearrange this word. In how many ways can we rearrange? Or in how many words can we obtain? Now they're telling us if we have 2 letters, they will tell you. The question will tell you whether you should treat these as 2 different or just one same whatever. Okay. So 5 factorial will represent the number of options that we have, number of ways. Then how you get the probabilities, we need to go over that as well. So when I quickly have a look at, now let me start with this one. Okay, in a survey, so they're using a table. where you have two options, okay, male and female, and failed and passed. So totals must add up, and then they're asking you to determine whether the test is independent. Okay, so they did not specify the gender, so you have the right to choose your own gender. So in this case, failing, okay, and the gender. So probability of failing and maybe your male. That will be probability of failing times the probability of being male. So on the left, failing and male, oh Lord, I'll just call it fail and male, okay? So you failed and you're male, it's 170 over 3,000. Then for probability of failing is 200 over 3,000 times probability of being male is 1970 over 3,000. So you check the answers. Please do not transpose anything. You kind of proving what is on the left and what is on the right. Get the answer here. We normally prefer decimals, at least to 4 or 5 decimal places. Same place, same option with the right-hand side. If you see that the answers are the same to at least 4 decimals, then they are independent. If they are not, then the events are dependent. Then here, events S and T are independent. You see that? Probability of S is the same as probability of T, which is Y. Then probability of S or T is this. So you have to apply that addition rule. They want the value of that. So S or T, we said is going to be S plus T minus probability of S and T. Now, what is S? It's a Y. What is T? It's a Y. Minus S and T, events are independent, so you multiply them. Is that what is happening? Is that going to make sense? Yes, 0.84. So that's a 2y minus y squared is equal to 0.84. It's a quadratic, you solve it. That's why it's 5 marks. Then 11.3, we have 7 bananas, 4 apples, 3 oranges, and 5 guavas in a fruit basket. How many arrangements are possible if the fruits were to be placed next to each other in a single row? Okay, we have 7, we have 4, we have 3, we have 5. We can just multiply those numbers. Answer we get, those are the different ways of how we can group them. Then we have the word stapled. If the letters are randomly selected and all the letters are used, what is the probability that a new word will start and end with a vowel? Okay, so how many vowels are there? It's just 2 vowels. How many letters are they? 1, 2, 3, 4, 5, 6, 7 letters altogether. So start by looking at what if there was no condition of the vowel, we would have 7 factorial. Those are the options, or those are the arrangements we would have. Then bring in the condition, whereby one letter is, let's say A, and then this is maybe E. I'll just say this position is taken, and then that position is also taken. How many positions are we left with? So wait, 2, 4, 6, 7. I'm only writing 5. Okay, this position is also taken. So I have 1, 2, 3, 4, and 5 places to play with. So I'll say 5 factorial. And then I multiply the ones by the end, and then 2 factorial, since the A and the E can switch positions. So that's how I would have gone about that. When I look at this other one, they're talking about probability of getting the first answer in a quiz is 60%. If the test answer is correct, probability of getting the second correct rises to 70. So this is more like a tree diagram, if you want to. So 60%, which is 0.6, that's if it's correct. And then if it's correct again, it's 0.7. So remember, every branch must add up to 1. So for wrong answer, this is going to be a 0.4. And then for wrong answer here is going to be a 0.3. But then they're telling you that if the first answer is wrong, the probability of getting the second answer correct is 0.4 or 40%. So that's a 0.4, and then this is a 0.6. This is correct. This is wrong. So the outcomes will be correct, 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 wrong, wrong and correct, and then wrong, both of them. Then they want the probability of getting the second answer correct. Now they are not being specific whether the first answer is correct or wrong, but the second answer has to be correct. So it's possible for you to get the first answer wrong and then the second answer correct. So that's 0,4 times 0,4 plus first answer correct and correct. So 0,6 times 0,7. Multiply that, give your answer either a decimal or a percentage. Remember, probability can be expressed in three ways. Percentages, fractions, and then decimals. Then here again we go. A and B are independent. They want the values of X and Y. Please and please and please. When you look at these Venn diagrams, B is going to be 0,4 because we are adding the 0,1 and the 0,3. A alone is going to be 0,1 plus X. And then this 0,1 is the probability of A times the probability of B, which is 0,1. And then apply your addition rule, A or B. So probability of A plus probability of B minus that, and then you apply what we have. So in that case, you're going to be looking for X. Then for you to get Y, you add up everything here. It must give you a 1 since we're dealing with decimals. Maximum probability would be 1. Then question 11.3, ping pong balls numbered 1 to 12 are placed in a hat. Every time ball is thrown, it is placed on a rack, one next to the other. How many different arrangements can the 12 balls be obtained? So that is 12 factorial. Okay. They are telling us assume that the numbers 8 and 11 must be placed next to each other. So these ones are going to move together as a single block. In how many ways can the numbers be arranged? So treat this like one block. And then you recalculate that. Then the numbers 2, 5, 6, and 9 are taken from the group of balls. Then 2-digit numbers must be formed out of these 4 numbers. How many 2-digit numbers can be formed? So you have 4 options, and we only need 2 options. So permutations and combinations, or we need to know. So guys, that's all that you can expect. I wish you all the best, and do prepare wisely. Thank you very much. Let's meet in the scope for paper 2.